Since the earliest of military conflicts, commanders and field units have needed to navigate the surface of the Earth with confidence. Knowing where friendly assets and the enemy's assets are located can not only be the difference between loss and victory, it can be the difference between life and death. Until the 1990s, satellite and other radio navigation systems were tedious to use and not very precise. In 1978, the first Navstar GPS satellite was launched. And with the system becoming fully operational in 1995, a new era in navigation had arrived. The Global Positioning System, or GPS, was deployed to provide navigation and timing information to American and Allied military users globally and in all weather conditions. GPS satellites orbit approximately 20,000 kilometers above the Earth and transmit radio signals. The transmissions are attenuated on the journey to the Earth's surface and arrive as a very low power signal. The system is based on a constellation of 24 satellites in 6 orbits acting as reference points for receivers on the ground. Each GPS satellite transmits 2 types of signals, those for civilian use and those exclusively for military use. Currently, civil GPS signals are on a single frequency and are not encrypted. They are therefore not secure. A second civil and non-encrypted frequency is also planned to be operational around 2011. Military GPS signals are encrypted to prevent access by unauthorized users and provide resistance to electronic attack. They are broadcast on 2 separate frequencies and provide slightly better accuracy than civilian signals. In order to use these signals, a GPS receiver is required. GPS receivers employ special signal processing technology that deals very effectively with the low power signals received at ground level. Civilian receivers are commercially available as dedicated handheld devices or as installed equipment in vehicles. They are also available as features in handheld computers, two-way radios, and even cell phones. The use of GPS technology in civilian applications has brought enormous benefits. We now rely on GPS for driving directions, airline navigation, police and fire services, wilderness activities, and even our golf games. The main benefits of GPS for military applications are accuracy, all-weather capability, ease of use, portability, global coverage. Civilian GPS receivers can only receive and process the civilian signal because the military signals are encrypted. While a keyed military receiver can track the civilian signal, it will normally track the military signals because a preloaded crypto key will allow the signals to be decrypted. However, if the crypto key is not loaded in a military GPS receiver, it cannot make full use of the military signal and is as vulnerable to electronic attack as a civilian receiver. Regardless of the signal being tracked, the GPS receiver will need ranging data from at least 4 GPS satellites to work out its position and time. For a GPS receiver in the open with a clear view of the sky, there should never be a lack of satellites as 4 or more will always be in range. But if visibility is restricted, either by buildings or a dense tree canopy, several satellites may not be visible and hence position and time data might be unavailable. To say that GPS has revolutionized military operations would be an understatement. The accuracy, security, and reliability of the military GPS gives the forces that have the ability to use it strategic and tactical advantages over an enemy that does not. American and Allied military forces are using GPS for many diverse applications, both during wartime and peacetime. These include navigation, tracking, bomb and missile guidance, search and rescue, facilities management, map updating, time synchronization, for example in secure communications. The use of GPS in military operational settings allows for smaller forces to be more effective on land, sea, and air. Military GPS receivers can be used on foot, in ground vehicles, on ships, and in aircraft. Currently, the Canadian Forces are using military GPS on operational deployments with great success. However, in spite of all the benefits, military users must be aware that GPS receivers are now electronic warfare targets, and that the threats to GPS are increasing. This is especially true of civilian GPS receivers. Therefore, the use of civilian GPS receivers is strongly discouraged, as such use can put military units at risk. Commercial GPS receivers can provide false and potentially misleading position information to the user. For example, if a commercial GPS receiver is used to compute target location coordinates, and if the commercial GPS receiver gives the user a false reading for the gunner's location, the target location coordinates, based on this false position, will be wrong by the same amount. This can result in collateral damage or a friendly fire incident. False position readings can be caused by enemy electronic attack or a GPS satellite signal anomaly. But whatever the cause, a civilian GPS receiver is far more likely to report a false position than a military GPS receiver with a current crypto key. Even more serious is a problem associated with certain commercial GPS receivers, such as the Garmin Rhino that features built-in two-way radios. These combined GPS and COM devices broadcast the user's coordinates to anyone within range over a non-secure unencrypted radio network each time a voice transmission is sent. The radio transmission can be intercepted by anyone with the same type of device, simply by using the built-in channel scanner. Once the radio signal is intercepted, the other user can display the coordinates of the sender and use those coordinates to target the sender or navigate to the sender's position. This obviously creates a risky situation in an operational military scenario. Always remember that the most secure and reliable GPS equipment for CF members in operational settings is a CF-issue military GPS receiver with a current crypto key. Since the GPS signal levels at ground level are weak, the amount of power required for a jammer to be effective is minimal. And since the same frequency is used for the civilian signals as for one of the military signals, an unkeyed military receiver is almost as vulnerable to jamming as a civilian receiver. When the signal is unreliable as a result of jamming or interference on the first military frequency, a modern keyed military receiver will switch to the second encrypted military signal and continue to operate. Civilian receivers cannot do this. A miniature GPS jammer can be powered by a single AAA battery and can jam civilian GPS receivers within walking distance. Military GPS receivers are also susceptible to this type of jammer, but to a lesser degree. Larger GPS jammers can transmit higher power and modulated jamming signals, which can have a greater effect on receivers. Effective range can be in the tens of kilometers. High-power jammers can also be deployed against GPS signals by fitting a jammer to a large amplifier and a high-gain antenna. Effective range of this configuration of these types of jammers can be in the range of hundreds of kilometers. GPS transmissions arrive at the Earth's surface weakened after a 20,000-kilometer journey. It is for this reason that these signals are vulnerable to jamming at ground level. Jamming can affect both civilian and military GPS receivers. The main difference is that when a civilian GPS receiver is jammed, it may quickly die. Even worse, it may appear to continue operating normally, but in fact be reporting false position data that can result in disastrous consequences. In addition, certain models of civilian GPS receivers can broadcast the user's position to the enemy. While military GPS receivers can be jammed, they are more resistant to jamming than the civilian GPS receivers. They have the ability to switch to the second encrypted military frequency and operate at near normal efficiency. The following demonstrations are intended to show these differences in military versus civilian GPS receivers. To demonstrate the vulnerability of commercial GPS receivers to jamming, a number of commercial GPS receivers were jammed in the lab and the results videotaped. Jamming strength will be illustrated using the graphical display at the left of the screen. This is the display of the first GPS receiver before jamming. It is tracking 8 GPS satellites and has an accurate solution. Observe what happens when jamming is applied. This receiver is off the air, completely disabled by jamming in just a few seconds. Next, another GPS receiver from a different manufacturer was subjected to the same jamming. The result is the same as for the first commercial GPS receiver. All GPS receivers are susceptible to jamming, without exception. A keyed military receiver is much more resistant to jamming than a civilian or unkeyed military receiver. Fortunately, keyed military GPS receivers, such as the CF Standard Issue Defense Advanced GPS Receiver, or DAGR, seen here, can track the secure military GPS signals and are therefore able to operate even in a jamming environment. Here, a keyed DAGR will be subjected to the same jamming as in the civilian GPS receiver demonstrations seen previously. First, the DAGR detects the jamming signal, and then a pop-up warning comes up on the screen alerting the user that it is being jammed. It then continues to operate. Now, observe the DAGR and one of the commercial GPS receivers again, this time side by side, subjected to the same jamming. The DAGR keeps on working after the civilian receiver dies. The DAGR gives the jammer warning and continues to operate. It is critically important to note that a military GPS receiver will only detect and use the military GPS signals if it is used with a current crypto key. If not, it will perform no differently than a commercial GPS receiver when it is subjected to jamming. In this demonstration, we see a keyed DAGR on the left, a civilian receiver in the center, and an unkeyed DAGR on the right. When subjected to jamming, the keyed DAGR continues to navigate. But like the commercial GPS receiver, the unkeyed DAGR goes off the air when jammed. Note that the unkeyed DAGR stays live only slightly longer than the commercial GPS receiver. In an operational setting, there are many techniques that can be employed to reduce the effects of jamming. GPS jammers are most effective when they have a direct line of sight to the GPS receiver. Therefore, obstructing the line of sight can be an effective method of reducing or eliminating the jammer effect. These include body masking, vehicle masking, and use of terrain. These techniques will be dealt with in operational training environments. Military GPS receivers are sophisticated devices that store sensitive information that, in the hands of the enemy, might present a security risk. Although a military GPS should always contain a crypto key, it is not a classified item per se, as the crypto key cannot be extracted from it. However, a GPS receiver may contain classified information, such as waypoints, indicating sensitive locations that would be prime targets for attack should their coordinates be known. Worse still, they might contain classified mission data. If it becomes evident that the GPS receiver might fall into the wrong hands, this information should be removed from the receiver by using the Zero Eyes function. Most civilian receivers do not have ready access to this kind of feature, or they do not have it at all. It is important to note that the loss of a military GPS receiver must be reported to the appropriate authorities, as it is a controlled item. The GPS equipment issued to CF personnel offers huge advantages to soldiers in a variety of military situations. The benefits of the enhanced situational awareness that military GPS offers CF members is clear. But with these benefits come certain risks that need to be managed with proper tactical approaches and appropriate action against enemy responses to the technology.